Hello and welcome to chapter 5 of this straight line course. Today we're going to be looking at gradients of perpendicular lines. And before we look at this, we need to know what we mean by the word perpendicular. So it's got the definition here. Two lines are at right angles to each other are said to be perpendicular. So what that looks like is two lines like this. If they're right angled to each other, then that line and this line are perpendicular to one another, as in they meet each other at right angles. You will have seen this before in real life, like if you have one road and another road, they're perpendicular to each other. We often use the word perpendicular and use the word parallel, meaning two lines that will never meet, so like two streets that will never meet. And then these two streets are like perpendicular to each other. And we have this fact here that if we have a line or the gradient of a line and the gradient of its perpendicular line, then multiplying them together will give you -1. So that is always true. Similarly, conversely, if we have multiply together two gradients together and it gives you -1, then that must mean that the two lines are perpendicular to one another. So that is a proof of whether or not two lines are perpendicular. And so we can use this fact here in order for us to work out the gradient of perpendicular lines. And one way to do it is by, it says here, inverting the gradient and changing the sign. So what that means is, this example here, the gradient of 2/3, you would flip the fraction, take the reciprocal, so the denominator is now the numerator, then you change it from a positive to a negative. So the perpendicular gradient of 2/3 is -3/2. I'm going to do another one here. If we had a gradient of, let's say, -4, because we know that every whole number is just a fraction over 1, if we flip this fraction, or this whole number, it would become 1/4. And it would go from a negative to a positive, so that negative will go away. Now it says here that these special case where if you have a horizontal line, a gradient of 0, it is perpendicular to a line that's vertical, and so the perpendicular gradient will be undefined. And if you have an undefined gradient, the perpendicular gradient to that would be a gradient of 0. Okay, so let's look at some examples here. So this first one, giving that t is the point 1, -2, and s is -4, 5. Find the gradient of the line perpendicular to st. So what we should do first is we should work out the gradient of st. So y2 minus y1. So 5 take away -2 over x2 minus x1. So that would give us 7 over -5. Now, a perpendicular gradient to that would be 5/7. We just flip the fraction, and it would no longer be negative, it would be positive. So the answer, the perpendicular gradient to st, so the gradient, I would write st here. Perpendicular gradient to st is 5/7. Okay, let's have a look at this second question. So it is asking, or it's telling you that it's got 3 points here. So the point 0, 0, -3, 9, and 12, 4, saying that this is a right angled triangle. It's saying that we need to show that it's a right angled triangle. So we have the 3 points here. This is O, M, P. This is the origin, always 0, 0 for O. 12, 4, negative 3, 9. And so all we need to do is we need to prove that this line MO and the point O, or the gradient OP, are perpendicular, as in they multiply together to give negative 1. Okay, so let's work out the gradient of MO. So y2 minus y1 over x2 minus x1. So that is negative 9 over 3. So the gradient is negative 3. Then the gradient of OP, y2 4 minus 0 over 12 minus 0. That's 4 over 12. So that is 1/3. So MOP and MMO, if you multiply them together, negative 3 times by 1/3, you would get negative 1. And so, I need a little bit more space here. So the question is asking, show that the triangle is right angled. And so you need to have since MO and OP are perpendicular to one another, the triangle MOP is right angled. And you could, here you could also use the converse of Pythagoras' theorem.